So next speaker is Peter Runcie, and Peter is the business leader, Future Cities, Transport and Infrastructure at Data61 CSIRO. That's one hell of a title you got there, Peter. Peter has held a range of technical and business roles in the ICT industry during his career. He has worked in both large and small organisations in Australia and the US, both technology users and with the vendor sector. Peter has a strong R&D pedigree working for Bell Laboratories, Avaya Labs, NICTA and now Data61. Peter is an inventor of over 25 granted patents in communications, data networking and biometrics, with others pending in structural health monitoring and data analytics. Peter has had practical experience with IoT systems, including leading a recent project resulting in installation of 2,500 sensors on Sydney's iconic Harbour Bridge. Please welcome Peter.
Thank you. Is this working? I'm not sure whether we can get rid of this thing on top of the screen here.
Oh, yeah.
So a couple of years ago, probably IoT, it would have all of it been about sensors. So a couple of years ago, it would have been all about sensors, and we can talk about sensors a bit today. But of course, things have moved on a lot since then. What I'll be doing is talking, I guess, a little bit about Data61. For those who don't know who Data61 is, I'm sure most people have heard of us, so I'll give a bit of an overview of us, what we do, and then look at smart cities and a couple of use cases, I guess, a couple of technologies, and looking at some of the bigger issues that we just heard from the previous speakers around the context of why we're doing some of this stuff. So it's a little bit of technology, but hopefully not too much for you, for those who are not tech geeks. So who's Data61? Who's heard of NICTA? Yeah, it's actually more than normal. Normally it's only about 10% or 20%. So NICTA is merging with CSIRO to form Data61. So Data61 is a business unit within CSIRO. As of 30 June, will be a part of the organisation. So we're going through a transition right now. What we do is we're obviously a research and development organisation focused on IT and ICT. And we provide advice, trusted advisor to government, so Angus Taylor and the state governments and local governments as well as industry and small business and startups. So we provide trusted advice around technology and technology policy, and we also undertake some research and development to help things along a little bit. We don't try and do all the R&D ourselves. Of course, it doesn't matter. It doesn't make sense to do that. Our role really is to tackle some of the more difficult things and then seed the industry and help startups and others to move forward. So we do that. But also internally, we are a service organisation for the rest of CSIRO. So the square kilometre array, genetic science, those sorts of things, the big data, big analytics type problems, we solve them internally for the other science programs in the organisation. And we have a remit as part of the NISA funding we heard about before, and we've always had this, a role to play in driving innovation in Australia. So not just SMEs, but through researchers, universities, etc. So from a technology point of view, the things we do around IoT are probably the things you'd expect, starting with things like data capture, sensing, which is one aspect of it, going through moving the data around. And a lot of these things have developed very, very quickly in the last couple of years. Our focus, and the reason we're called Data61, is it's all about data. These days it's about data management and data privacy, data analytics. Those are the sorts of focus areas we've got right now. We still do the rest of those things, and there's still development happening in new wireless technology. So our Wi-Fi lab, for example, are looking at new things to do with intelligent transport systems. But a lot of the focus now is on security, managing data, the data governance, and also at the bottom there you'll see behavioural economics. So it's how do you help a society introduce new technologies, and how do we understand human behaviour when it comes to rolling these things out. So that's the sort of things we do, both in IoT, but we don't think of it as IoT, we think of it as cities or agriculture or any other market sector. IoT is a sort of across the board there. So we're about 1,100 people, a lot of students, so 2/3 of ICT PhDs in Australia come through us. We have relationships with all the leading universities, so we work with them and they're complementary to us, and we try and drive business through. Over time, we're hoping to bring a lot of research and development into Australia and play a facilitation role in doing that, and feed that back through to universities and researchers and back to the SME sector as well. So that's what we do. As far as our innovation system, I think I've talked about some of these things, and maybe at the panel discussion we can talk a bit more about them. There's some strong programs in place and being developed around working with governments, working with the startup community and enterprises. So smart cities, if we say, what do you think of when you think smart city? Everybody's got a different answer. Some people think flying cars, that was added recently. The younger generation might think flying cars. Some of these things are technology, some of these things are around outcomes. If we focus on one of these things, what's the impact on other things? So smart cities is quite a range of different things, and we could all add more to this, of course. And it'll probably evolve over time. So when we're looking at some of these systems in the context of a bigger city and what are we trying to do, and I think we heard about this from the other speakers, I think there's probably two things we need to keep in mind. One is livability. We need our cities to be livable. If we put more cars on the road, then there's an impact on congestion and environment, of course. There's trade-offs to be made, and we need to understand what those impacts are. So at the top level, livability is very important. If we don't have a livable city, we won't have people coming in and staying in that city. And conversely, economic sustainability is important as well. We need our infrastructure to be working hard and cost effectively, and together these things allow us to grow our cities. So sensors, there's still work happening in sensors. The bottom one here is a micro sensor that we've developed a couple of years ago now for honeybees. It's a very simple RFID chip. They can be printed off. Next generation of these is going to have different types of environmental sensors in them, and you can imagine we'd be able to sprinkle these into the environment and collect data. So that's great. That's a advanced sensing technology which we can make available. There's not a lot of smarts to it. It's just the sensing. When we look at applications of sensing in the infrastructure space, for example, we look at the top example here. So this is a bridge which is not too far away. It's got 2,500 low-cost sensors on there that collect vibrations, and they monitor the structural integrity of that bridge. So I had a slide earlier with all the different things we do: data collection, data communications, processing, data analytics and machine learning. That's all part of this system. And importantly, user interface design, user experience design is also part of this. In this particular case, what we're doing, and I think the next slide might actually show it, what we're doing here for the asset manager, and here we're talking about economic sustainability, we're making our assets work harder and last longer. We're giving the asset manager a web page and a mobile app that he can use to keep an eye on his bridge in real time. So this is updated 3 minutes ago. If there's an issue with that bridge, then he can send someone out to do some preventative maintenance. And the idea is that by knowing the condition of that structure, we can extend the life of that structure by getting onto things when they need to be maintained rather than waiting too long, or doing it too early, which is inefficient as well. So that's one part of the infrastructure and one application of IoT. And I'm not going to talk too much about equations, but I thought I'd mention machine learning and analytical techniques, because if you're a startup and you're involved in some of these types of solutions and you're looking to extract information from these technologies and try and understand it, then you could have looked at some of the physics-based techniques that come out of a lot of the university departments. So in the case of a bridge, it's engineering. It's how does concrete behave, for example. They're really good, but they're limited. They're very hard to work with in the real world when it comes to predicting the behaviour of something like that structure we just saw. So physics-based approaches to analysis do play a very important role. We need to keep doing those. In the last decades, I would say, there's been a lot more work around simulations and numerical modelling, where we're simulating an environment. We're not actually trying to model how that concrete and that bridge deteriorates, for example, but what we're doing is making a simulation. And here's a picture of a city simulator game. And you can make some predictions to some extent about how things behave, but it's limited by the rules that go into this system. So it's got some limited application. Still useful, they're both useful, but it's got some limitations. If you look at big data, so lots and lots of information, and how do you make sense of that? And I've got new here, but really it's not new now. I mean, it's still evolving, but this is machine learning and deep learning and those sorts of things, which is, I guess, a couple of years old and still developing. What we're doing is saying things are so complex, there's so much data of different types that we really can't try and understand how it works. What we're interested in is what information can it tell us? What story can that data tell us about the condition of the bridge or the condition of the road network, or how the environment's going to be changed tomorrow if we make some tweak to traffic lights, for example. So machine learning and data analysis is another type of analytical technology. The three go together. So in practice, we try and use all three together. And there's lots of skills around the place looking at each of these three things. Part of the challenge is using them together in the right way. So I think that's the only slide with an equation on it. I'm not going to provide another one. So I'll give you two examples. I think we saw some bubbles around autonomous vehicles, energy, et cetera, So just looking at two, these things are developing, and there's two columns here. One is around autonomous vehicles, so this is self-driving cars. It's an Internet of Things application, but really what's happening in the car is it's doing everything itself internally. And then on the right-hand side, we've got that autonomous vehicle, or even a non-autonomous vehicle, connected into the infrastructure. So this is what's called cooperative intelligent transport systems. In Australia, New South Wales is leading the way in terms of trialling these technologies. So we have a trial running with Transport for New South Wales. I'm not sure whether the clicker works. Down in around Port Kembla, and the idea is that the vehicles are communicating with each other and with the roadway to get a more efficient and effective solution. So this is great, and that's in development. There's plenty of work to be done. There's lots of interesting technical challenges to be solved. There's issues around liabilities and insurance for autonomous vehicles. There's other things which aren't really being addressed around things like security. Can we use the data there for purposes which it's not intended to be used for? So there's some impacts there potentially, and some things to be looked at. There's also other things that we need to think about. So it's great having autonomous vehicles, and it's great having all these trucks driving really close together in a platoon. But what happens if you're driving out to Bathurst and there's 8 trucks all in a row with about 1 centimetre between them? How are you going to overtake? So there's some considerations here which we can think about. So congestion, autonomous vehicles. If people drive their cars to work, or have their cars drive to work for them and then circle around the block while they're waiting to pick up their coffee, there's going to be congestion. But potentially. These can be managed, and I think to the point that was made by Tim earlier around policy and around thinking about these things early, we can address some of these things. If we don't think about them now, I think we've got a potentially an issue. And they relate back to livability, and they relate back to economic sustainability of our cities. So urban sprawl, we've heard about the 30-minute city. Again, if we have this self-driving car and we can work for 2 hours in the car on the way to work, well, does it matter whether it's 30 minutes? Maybe not. So maybe the city gets bigger, exacerbating the issue with urban sprawl. So again, looking at each of these technologies, we need to look at them in the scheme of the bigger picture, and understand, if we were to roll out these autonomous vehicles, how do we actually try and understand through analytics, for example, what the impact is on the environment as the cars are circling around waiting to pick up their cup of coffee, or the 1.5 hour commute each way. If autonomous vehicles aren't parking, then who needs parking stations? Airports are very worried about this because it's a big economic contributor to their revenue. But alternatively, the space can be redeployed. So in CBD locations, maybe we don't need that many parking stations. If people have got these great cars, then why would they even need public transport if they're happy to sit in their car? So we're all of us interested, I think, in public transport and things like personal mobility, where we can go from A to B and use the most appropriate means of transport, whether it's walking, cars, trains, or whatever. But if our car is so comfortable and does everything for us, why would we even tell it to stop at the train station? It might as well go straight through to the city. So there's some social and behavioural aspects we need to try and understand here as well. Maybe fewer cars. I think we've heard about some of these things before. Maybe there's more pedestrian activity. Maybe there's less pedestrian activity. It's important in the city if we have more people walking by retail stores because it drives business, and the economic growth of that city is partly dependent on pedestrian activity. So, but do we really understand what the impact is on that? And ultimately, it's driving positive impact on livability. I focus on transport here, but there's other things as well, of course. So it's a bigger picture. But I've only got 20 minutes, so I'll only cover one small piece of it. So what can we do? We can try and understand what's going on. So here's a simple dashboard. Well, it's not a dashboard, it's a report of road information that RMS have based on the loop detectors in the road. It's very straightforward. It's quite powerful. You can go to this yourselves. It's on the website from RMS. and you can work out whether to go across the split bridge at 8 o'clock in the morning. I wouldn't recommend it. You can see here what the average speed is and travel time. So this is one way of getting a bit of a handle on what's going on. It's not particularly fancy or comprehensive, but it's useful. So this is step one, which is visualising one part of the system. If we then say, okay, well, what's actually going on here, and trying to understand behaviour, again, within a road system in this case, just in isolation around the roads with the same sort of information. I'm not sure whether this is, yeah, this is operating. So here we've modelled some streets in Sydney CBD. The green roads are uncongested, the yellow ones are congested, and the red ones are the ones that are the ones which became congested before the yellow one. So it's the how do you describe it? It's the causes. So what we've seen in the data analysis here is that these little red roads here, they basically predict congestion further in the road network. So what we're looking for here is knock-on effects. So we have a visualisation, but we're also getting an understanding of knock-on effects. If we close this road for George Street Rail, what's the knock-on effect, and what can we do about that? So we're getting a bit of analytics into this now. And then I think Tim might have mentioned dashboards. So dashboards, of course, at a high level, visibility is fantastic. And if you're running a city or a government department or any business really, knowing what's going on is important. So here we have a whole range of things which could be important to a city manager. And it's great, and there's a lot of focus from these people on the way it looks and web design and those sorts of things. But behind the scenes, there's a lot going on. I mean, there's a lot of data sources. So here we start looking at where are those data sources coming from. They're coming from different organisations, and there's potentially privacy concerns. When you look at these numbers, if one of them's updated every minute and one's updated every 6 months, then you may have the wrong impression about the quality of the data. So there's some education to be done around these things and helping people understand what they actually mean. And each one of these is going to be different for each purpose. So dashboards is the visible part. Below there's a whole lot going on around data stores, data security, those sorts of things. And it comes down to complexity. So here's a very simple sort of model showing, we can look at the roads or the cars, but then you can look at mobility at a higher level, and you can take some metrics. You can look at your 30-minute city. But when you do that, you really need to understand where the jobs and where the destinations people go. So when we start looking at these 30-minute cities, and you want to have a little tile on your dashboard that says, did we achieve 30 minutes today, or what's the average minutes today, you actually need the other information as well. You can't measure that. You have to calculate it, but you need information from the other parts of the city. And so it's an organisational issue in terms of governance, but it's also a data security, data privacy concern as well that can be addressed. And if you look at livability at the top level, then again, you've got all this transport stuff going on, but what about the environment? What about people? What about the culture? What about health? So the picture gets bigger and bigger. And of course, it's not a hierarchy, it's a complex web of interactions and organisations and data sources. So complexity is one thing. I don't think I've probably got time to go. How much time have I got? I'm okay? Yeah. So, and an example is traffic congestion. So it's not just a matter of looking at, as we saw before, at the road network and the loops and the data showing how the roads are congested. To really understand it, we need to know about supply, demand, and behaviour if we want to make a difference. And again, the data that comes into play here comes from different types of government departments and private enterprise. There's potentially private information here. So your Opal card for public transport, you don't want to give that away. It's necessary to get an understanding of what's going on. And then there's information about urban planning, capital works programs, etc. So it's quite complex, but well worthwhile doing it, but there's some considerations. So one of the technologies that we're working on to try and address this is what we're calling confidential computing or distributed analytics. And it addresses the problem where we have data in multiple locations and we don't really want to share that data. So the data owners don't really want to share it or risk it becoming exposed in the environment. So the idea is that in a federated data model, so we have the data staying where it is, so in the government department where it belongs, and not being collected into a central location, which is the way a lot of these things are going these days. In this federated or distributed data model, we have different organisations. We have organisation 1, org 1, org 2 and org 3. And let's say org 1 is the organisation that wants to understand livability and measure that and be able to calculate what that is. without, and they need to draw upon information from maybe it's a transport department or some other system. The idea here is that we keep the data in those locations. The red area is the untrusted area, so we don't want private information going outside of the borders of these organisations. What we're looking to do, and what we're doing on a small scale at the moment with some fairly simple calculations, statistical calculations, is encrypting that data and doing the calculation or the analytics in situ as it's encrypted without getting any of the important information out, just the results we want. So we're getting the insights out into the untrusted area, which is the organisation one there, but the private stuff and the confidential stuff stays where it is and doesn't come out. So that's very exciting for us. It applies in this sort of situation, but it applies in all sorts of other things as well. So that's one part, it's a technology part of the puzzle, but of course there's more to it with the organisational and governance parts. So moving forward, I mentioned behavioural economics and understanding people's behaviour. It's important to have things like living labs, demonstrators. Trials are important, so I think that's wearable tech from 1950 on the top right. So things like living labs, and there was mention made, I think you made a mention earlier about the one in Kansas City, where they're using that as a living lab. They're trying to understand and play with their technology and understand some of these issues. We should be doing the same thing. We are in some areas, but we could be doing more around urban living labs. Understanding people's behaviour and actually doing it scientifically. So if we roll out a new tech or we make some change to the city, actually understanding what the impact was in each of the different areas. So were they happier, were they not as happy, were they healthier, not as healthy, and doing it in a scientific fashion. And then collaborations, of course, which we've heard from everybody here. I mean, it's all about collaborations across the industry and with government and the community. And I think that's it. Thanks.